Okay, come, let's start today's class. Now, what was the homework? The homework is this one, right? 5, 6, and then this mock exam paper, right? Now, for those who have done it, go and give yourself a tick. For those who have not done it, what I would advise you to do is just to go back home. You just go and do the questions that you have not done. So, because these are all things in which I want you all to be able to become comfortable doing. Okay, so now question 5 over here. If you got this correct, go and give yourself a tick over here. Now, if let's say you got wrong for this question, please let me know. I will go through it. Okay. Now, question 5 over here, the equation of the curve is this. Find the value of dy over dx when x equals to 2. So the first thing we have to do is separate them out. Separate them out, then you go and differentiate accordingly. This one is page 7. Page 7 over here. Right? Okay, so when you sub in x equals to 2, your dy over dx is 5 over 3. Okay, so if you got this correct, give yourself a tick. Now, second part over here, show that the equation of the normal at the point of x equals to 2 is this one. So y is equals to, okay, there's a typo over here. It shouldn't be pz, it should be px over here. Okay, so the constants should be r equals to -1, your q equals to 6 over 5, and your p is equals to -3 over 5. Did we manage to get that? Did we manage to get that? Okay, very good. This one over here. Okay, come. So, Nihal, right? Okay, Nihal over here, right? He has this portion over here. He wrote it as, Nihal, your answer is y equals to -3 over 5x plus 6 over 5. And then what? Plus what? Plus ln 1. Plus ln 1 over 3, right? Yeah. Now, Nihal is very, very close. If you manage to get here, just remember, ln 1/3 can be written as ln 3 to the power of -1, correct? Then what you can do over here is to bring the power to the front. So this one will be... No, your answer will be accepted. Only the first two will be accepted. So your this one and this one will be correct, but your this portion over here, you should rewrite as -ln 3. Okay?
But why they're not the same?
No, not the same, because this one is plus r ln 3. Because if it's ln 1/3, then your answer might correct. But they want it to be ln 3 over here. So this one, something just take note. Okay, can. Okay, now, sorry, for those who have not done it, you all please go and try it. Okay, now over here, right, this is a bonus question. This is a very, very good question. Let's see whether we manage to get it. Now, the graph of the dy over dx, this one should be dx of the function y equals to function of x, is shown in the diagram below. This one over here. Without finding the equation of the function, state the x coordinates of the stationary point on the graph of this one and determine their nature. Okay, now let's go and take a look. This is my graph over here. Okay, so let me just do this. Sorry, just give me a short while. See if there's photos over here. Oh. Okay, now stationary points means what? Everybody?
dy over dx equals 0.
Yes, thank you very much. Dy over dx equals to 0 over here. So this means dy over dx equals to 0. Now I have a couple of points which is stationary. This one over here, this one over here, and this one over here. Okay, so I have 3x coordinates. So when my x is equals to 1, my x is equals to 3, and my x is equals to 7 over here. Okay, now we can find out the nature of their roots, which is d square y over dx squared. If it's greater than 0, means to say that this is a minimum. Okay, and my d square y over dx squared smaller than 0 means it's a maximum. Now this one we know, right? So what does it actually mean? So minimum goes from your negative it goes from negative to positive over here. For your maximum, it goes from your positive to your negative.
The stationary point is area of the curve is like
Yeah, right. Okay, so Nihao is asking this question. Shouldn't the stationary point be this point, right? This point and this point over here, right? That's your question, right? Now, why is it not these points? Can I ask the class, why is it not these points? Why is it not here, here, and here? Yeah, right. Niha's question was, hey, stationary point is like that, what? Why? Why teacher Wilson say is here, here, and here? Because the vertical axis is dy over dx. If the vertical axis is y over here, then you're absolutely correct. If it's y, then Nihao will be correct. This one is all the stationary points. Okay, but this one is your dy over dx, so that's why these are all the points over here. So minimum, it goes from positive to negative. So what kind of point is this? There's only maximum minimum point. Why is this okay, what point is this? Wait, go from the class, we sneak around the class. What point is this one? What kind of point is it? Maximum, minimum, or do not know? Minimum, Is it minimum? Maximum, Maximum, how? Lolin, what do you think? What point is this one? What kind of point is maximum, minimum point? Minimum point. You? This one, yeah. Don't know. Audrey. Not too sure. How? Okay. Again? No. Nihao. Don't even. Have. Okay, come on. Okay, conventionally. Okay, let's go and see. Conventionally, this is a maximum point, right? This is a maximum point. Agreed? So what is the gradient? What is the gradient over here? Is it a positive or a negative? Positive, right? So this one is positive, 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 0, negative, 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 negative. So I'm going from positive to negative. Now, looking at this portion over here, what kind of curve is this? It goes from positive to negative. Yes. So over here, this one should be a maximum. Positive, positive, positive. Yeah, it's going down, but this dy over dx. This is a positive dy over dx. This is not y over here. You get what I mean? Okay, so dy over dx is the gradient, right? So the gradient over here is positive, 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 0, negative, negative, negative. Agree? The gradient. So in this case, this one should be a maximum curve. Yeah, so over here, this is a negative value. This is negative, 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 0, positive, positive, positive. So this one should be a minimum. Okay, can? Okay, now, next question for the class. This one, maximum, minimum, or what? This one. What kind of nature is this? That's a second derivative.
why not?
Thank you very much. Point of inflection, because this is positive, 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 0, positive, 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 positive. So this one is point of inflection. Okay. Now, any questions for this bonus question? Do we understand the concept? Can. Okay. I'm not talking rubbish, right? Okay, okay, very good. Now, Part 2 over here, state the range of values for which x is an increasing function. Now we know that dy over dx is greater than 0 over here. Now the range of values in which your function is increasing, this portion over here is my increasing, right? dy dx is greater than 0, right? Now the second one over here is this one over here. And then the last one over here will be this. Okay, so these are the range of values in which your function is an increasing function. Now this one is a tricky one, right? Because this one is your dy over dx. That's your vertical axis. Okay. Okay, so far? Okay, okay, please go and write that down. Okay, now can we move on to our homework one? Any questions you all didn't know how to do it? Any questions that you want me to go and explain? Question 4, okay. So I have question 4. Anything else? Question 3 over here. Anything else? Don't tell me question 2 and question 1. Okay, so for those who managed to do it later, I'll mark your work. So let's take a look at question 3 over here. Now, question 3 is your standard rate of increase, right? Your connected rate of change over here. So water is poured into the bucket of this. So that means to say dV over dt is 25 pi cm cube per second. The volume of water in the bucket when the depth of water is x is given by this. So this is my expression for my volume. Find the rate of increase in the depth of water when x is equal to 5. Now, the question wants me to connect my dV over dt with my dx over dt. Now, the way that we connect them is using our dV over dx. So this over here is a question mark. I do not know what is this. Okay. Now, I know what is this value. The next thing I have to go and find is my expression for dV over dx. So my dV over dx, first and foremost, I need to go and settle my volume over here. This is given by the question. Volume is pi x squared 15 divided by 3. I will do here is expand out the bracket to get this. 15 pi x squared minus pi over pi x cubed over here divided by 3. Okay, I expand out the bracket. And then later, I will just go and separate them into two different terms. 15 pi x squared divided by 3, which is 5 pi x squared, and this one over here. Okay. Now, once you have this expression, you are all primed, all set up to go and find out your dV over dx. So dV over dx is this. So bring down power minus 1. So when x is equals to 5, my dV over dx is equals to this. Okay. Now, go and copy this down. Okay. So this is your finding out your dV over dx over here. Okay. Now, once you are done, okay, you just have to connect everything together. dV over dt is 25 pi. dV over dx is also equals to 25 pi. Then you can find out what is your dx over dt by bringing 25 pi to the other side. So dx over dt is 1 cm per second. Okay. Okay, for those who managed to get this, give yourself a tick. dx over dt is 1 cm per second. Okay, you managed to get it? Yeah, can I? So question 3 was asked by, was it you? No, Lolin, is it? Oh, you, huh? Okay. Are we okay? Xingyi. Okay, Question 4. Can we take question 4 is you, right? Okay. Come, everybody, let's take a look at question 4, and then after that, we'll begin with a new mock exam paper over here. Now, question 4 is a very, very important one. I'll need to go and correct whatever that we are doing over here. So, question 4 is this. I'll read together with the class. A piece of wire P cm long is bent to form the shape in the diagram, which is this. ACDE ACDE is a rectangle. AE is equals to Y. ABCD is a right angle triangle. And this is 13x and 5x over here. Okay, now they want me to express my P, which is the perimeter of this wire, in terms of x and y over here. Okay, so this one is not difficult. My first step is to go and find out this length, right? Because once I find out this length over here, this is, I can find out what is my ED expression. Okay, so over here, can we agree I'm applying your Pythagoras theorem? This is Pythagoras over here. Okay, so applying your Pythagoras, 13x squared minus 5x squared, this one will be 12x squared. So this portion over here is 12x. Now, once you are done, right, your perimeter, in this case, right, I started from B. So 13x over here plus 5x over here. And then I have 2y and then my 12x over here. So when I add them together, I should have P is equals to 30x plus 2y. Okay, so give yourself a tick if you manage to get this correct. Now, next part, they say that given that the area enclosed by the shape is 96 cm square, so in this case, I need to find out the area of the triangle and this rectangle over here. So I need to show that my P is equal to this. So first and foremost, this is my triangle. So half times my base, which is 12x, times my vertical perpendicular height, which is 5x over here, plus my rectangle. So my rectangle is 12x and this one is y over here. Okay, and this is equals to 96. So what I have done here is to simplify all of them into one very nice equation. Okay, now this 2y over here, this is, I got this from your previous equation, right? So I just bring my 30x to the other side of the equation. So 2y is equals to P minus 30x. So this is my second equation. Okay. Now this one is just more of a simultaneous thingy, right? So I sub my second equation into my first equation. So 30x squared, this one is 6x times, this is 6x times, 6x times 2y over here, because this will give me, 12xy. Okay, this one is 12xy over here. Okay, so once I got this, I managed to go and make P my subject. So this should be my answer over here. Okay, can Okay, I give you all one more. Now, the last one, please follow along because this is where students will lose their 2 marks. Okay, I'll tell you what's the issue with this next question. Now, the issue of the next question is that this. They say, hence, find the value of x for which P is a minimum value. So we know that in this case, right, minimum value, that means to say my dP over dx is equals to 0. Okay, so let me just go and write here. This over here means dP over dx equals to 0. So number one thing is that you need to go and find an expression for my dP over dx, right? So this is my P. So I want to differentiate my dP over dx. So dP over dx is just this. Okay, I get an expression for my dP over dx. And my next thing, right, is to equate it to 0. Okay, I have this one, 25 minus 16x squared equals to 0. So 25 equals to 16x squared. X squared is equals to this. Now I have two x values. One of this and another one is negative. Now you must reject this. You must reject this. If you didn't reject this, this will be a mark gone. Because having a negative x values will make no sense in your dimension, right? Because your dimensions over here is as such, right? This one is 13x. If your value is negative 4 over 5, right, then this one become a negative dimension. So in this case, I need to reject this negative 4/5. Okay. Now, this would only give you 2 marks. I repeat again. This portion over here will only give you 2 marks. Your next 2 marks comes from checking. Now, I know there's only one x value. I know. But then you need to go and check. That means to say you have to find out the second derivative of your p over here. Okay, you need to go and find this. Then you sub when x equals to 4/5. You want to make sure that this one is greater than 0. So you can safely say that this is a minimum point or minimum value. Okay, let's use their words. So in this case, this one will be a minimum value over here. Okay, so this is your other 2 marks. This portion over here and then this portion over here. Okay, so this one is a part where you usually, or rather students usually miss. So remember, once you find out your x value, you need to go and check it out. Okay, you need to go and check it out. Okay, so go and copy this down. Now, I will pause here first. Any questions for this particular mock exam paper? Yes, come, ask me. Huh? Yeah. So this one is increasing or decreasing function, right? There's a less than 0 or greater than 0. Less than that one will be, this one over here will be an increasing or decreasing function. Minimum value means your dt over dx is like stationary point, right? Okay. Okay, are you lost? Let me. Okay, now, so over here are 2 different things. Good that you clarify and good that Nihao's clarify also. So, when they are talking about increasing function, then dy over dx must be greater than 0. When they talk about decreasing function, dy over dx lesser than 0. If they talk about minimum value, this is dy over dx equals to 0. This is known as your stationary point over here. Okay, so different things are. So what Nihal and Lolin is asking of is this portion, increasing or decreasing function. Minimum value means to say that dy over dx equals to 0. It could be maximum point also. Okay, if they say maximum value, it's also dy over dx equals to 0. Okay, can? Increasing when you, okay, so for you, right, if you are looking for a word, right, when you say increasing or decreasing, this is where you're looking at this one. When you talk about maximum or minimum value equals to 0. Okay. Where it says, if they say, when they say maximum, same thing. This one also. Okay. Okay, can Okay, now, any other question other than 3 and 4? Okay, for those who have done, I will mark yours later. Okay, now can we all go to our, you do until where? Ngee is it? This one over here, huh? Ooh, wow. Ooh. Okay. Come, everybody, can y'all go to page 28? Is it page 28? Yeah, haven't done that. Okay, page 28 over here. Hey, this is the same example as my farm story, right? Remember my farm story? Remember? This is my farm story. I'm so happy. Oh my goodness. Okay, now the perimeter of a rectangle measuring x cm and y cm is 60 cm over here. So can we agree this is my x and this is my y over here? perimeter is, let's call it P, perimeter over here is equals to what? Yes, thank you very much. 2x plus 2y over here. So in this case, can we agree that this is 60 equals to 2x plus 2y? So that means 30 over here is equals to 2x plus y. Okay, now, what should I do next? Can we agree area is x times y over here? So x times, we need to rearrange this, right? I need to make y the subject, so y is equals to 30 minus x. So this one simple stuff. This is 30 minus x over here. So this one is 30x minus x squared. Okay, so this one is area. Easy stuff. Okay, this one just copy down. Now, part 2, find the value of the A when x is increasing at the rate of this and A is increasing at the rate of this one over here. Okay, now let's get Yan Hao to help us. Yan Hao, share with us. There are two things in which we need to go and address. This one and this one over here. Can you share with us how can I write these two in an equation? Dx over dt is equals to, okay, this one is cm per second, and then the second one is, yes, dA over dt is 7 cm square per second over here. Okay, Ken, don't worry. Okay, now, Angeline, what should I do to connect these two together? I have a dA over dt and a dx over dt. How do I combine them together? Okay. Yes, thank you very much. Okay, so this is how we connect them all together. Now, in our previous question, we already found out what's our A. My A over here, A is equals to 30x minus x squared. Audrey, dA over dx is equals to, help us with this, what do we get? 30? Yes, 30 minus 2x over here. Okay, so we have to find the value of A, Miss Po, what should we do next? I got this one, I got this one, I got an expression of this one over here. So what should I be doing? So what? So what and what? How do I connect everything together? Okay. Okay, so this one is 30 minus 2x times 0.5, and this one is 7 over here, right? That's what you're trying to say. Okay, so let's go and solve this. 30 minus 2x is equals to 14 over here, right? 14, right? Then negative 2x is equals to negative 16, if my math is correct. My x is equals to 8 over here. Correct? Okay, now, Lovin, are we done? Seems like it, right? No. Why? So how do I proceed from here? I found out the x value, so I need to find A. How? Yes, thank you very much. Okay, can everybody go and sub it in? So when my x is equals to 8 over here, my a is equals to 30 times 8 minus 8 square, which I do not know. This one should be 240 minus 64, which is equals to... Okay, somebody give me the answer. What do we get for this one? 176. 176, what? Meter square? Square. Yes, cm square over here. Okay, so this one is our area for this particular question. Easy enough? Okay, now, second question. Okay, can I give you all some time pressure? Question 2 and question 3. This is what? 7 marks. 10. Okay, can I give you all 10 minutes? Please go and try question 2 and question 3 by yourself. After 10 minutes, I will go and review the answer. Okay, so 10 minutes on the clock. Don't worry, Elise, I will show you the question. Come, everybody, let's go. Increasing function. Show that this one cannot be. Hey, yes, sir. How can I help you? I'll do it. How will it be? Okay. So, can you tell me if I had a connected power from what is that maximum? Define. So half minus half. Yes. So maximum value is half and negative half. This one negative half. Half and negative half. Now we solve the equation, sister. Yeah. Okay, check. Only six. Right. Yeah, I'm sure only that's very close. Four more and then you will be there already.
At least 1 minute.
At least one digit is correct. Don't cry, don't cry. Okay, good. Okay. Okay. Yeah. Yes, dy over dx equals 0, stationary points. Very interesting. All right, come. Up. Yeah. Hey. This one. Yeah, something not there already, huh? Okay, come, everybody. Let me steal your attention. Somewhere around there, somewhere around there. Now, let's start with question 2 over here. Show that this one cannot be an increasing function for all real values of x over here. Now, I think everybody managed to find out the expression for dy over dx. This is 1/4. Differentiate cosine will be negative sine to x. Remember to differentiate the bracket minus half over here. Okay, now everybody should be getting this negative half sine 2x minus half over here. Now, I just want to draw the graph for everybody to see. If you do not know how your negative sine 2x look like, it will look something along these lines. Okay, this is your y. This is equals to your negative half sine 2x over here. Maximum value is half. Minimum value is negative half over here. Agree? Okay, so now, can I just write out this part? Negative half sine 2x is in between half and negative half. Right? Okay, now, because I still have a shift over here, a vertical shift, this is negative half. So can I just add the negative half? So over here, negative half minus half is in between negative half sine 2x minus half and half minus half over here. Okay, so this is negative 1/4 negative half sine 2x minus half, and this will be 0. Now, this expression over here will be your dy over dx. So negative 1/4, this is dy over dx over here. Okay, so your dy over dx will fluctuate between less than 0 and more than negative 1/4 over here, correct? So therefore, or you can say, you can conclude, since dy over dx is less than 0 over here, the function cannot be an increasing. It cannot be increasing lah. Cannot be increasing. Okay. Does it make sense for you? Now, this part is something new for you because you never write in your trigo function before. Okay, so there is a range for your trigo, right? Up, down over here. This is your maximum. This is your minimum over here. Okay, and so far. Now, second question over here. The equation of the curve is this. Find the stationary points. Now, everybody managed to get this, right? This is dy over dx equals to 0 over here. Dy over dx equals 0. Now, you will have two different points. It's just how you manage to get that. So, y is equals to x squared plus 16x to the power of negative 2. dy over dx will be 2x plus 16 negative 2x to the power of negative 3. This is 2x negative 32 over x cube over here, right? Now everybody got this. So the only part which everybody did, or like some of you didn't get, is this portion. If my dy over dx is equals to 0, 2x minus 3 over 2x cubed is equals to 0. Okay, so this part I do not know why you want to complicate yourself. 2x is equal to 32 over x cubed. 2x4 is equals to 32. Then from here you can continue, right? X to the power of 4 is equals to 16, not 18. Okay, and then over here, x will have two values. X is equals to negative 2 or 2 over here. Okay, now the question is asking for coordinates, right? So that means to say, I need to have an x and a y. So, when x equals to negative 2, my y over here is negative 2 squared plus 16 negative 2. Sorry. Negative 2 squared. So this one should be, what is it? 4 plus 16 over 4, right? Which is equals to 8 over here. Okay, and then the same one, right? When x equals to 2, this one should have the same y value. Okay, because I squared. So that means final answer, negative 2 and 8 will be one answer, or this one will be 2. This one should be coordinates, this one should be n. Okay, so one answer, second answer over here. Okay. Now, determine the nature of this point. Yan Hao, what should I be doing? Second derivative test. So, if my dy over dx is equals to 2x minus 32x to the power of negative 3 over here, my d square y over dx square is equals to 2 minus 32 minus 3x to the power of negative 4. So this is 2 plus 96. Is it 96? Okay, 96x to the power of 4. Okay, so you sub in just the x coordinate, right? So when x equals to 2, my d square y over dx square is equals to 2 plus 96 over, this is 16, right? So what do we have? I do not know. 8. Sorry? 8. Okay, 8 over here. And when x equals to negative 2, d square y over dx square, again equals to 2 plus, same thing. This one should be 16 also, right? Also equals to 8. Okay. So that means to say d square y over dx square equals to 8 means what? What kind of point? What kind of nature is it? Huh? Sorry. Minimum point, right? So this one is my minimum point. This is minimum. And this one over here is minimum also. Okay. Okay, come everybody, let's take a 5 minutes break. And when we come back, we will continue on with this portion. Okay, come, let me mark you. Let me see.
I so bad.
Okay, are we all okay? Okay. Very cool, very cool. Sorry. Okay, come, everybody, let's continue here. Now, question for the class. Do you all want to try? Do you want to try question 4 by yourself and then we do question 5 together? Okay, can I? Okay, question 5. Wow, then 2 marks. 2 marks or 2 minutes, right? Okay, give your 3 minutes. Sorry?
The presentation,
Oh, what's this?
the temple.
This one is page 31. 31. Okay. I give you 5 minutes. Okay, come everybody, 5 minutes. Please go and try this question. Oh, okay. For those who have forgotten how to differentiate f to the power of e to the power of function of x, dy over dx is the first derivative of the function times the entire y over here. 2e to the power of 2x. Okay, come everybody, let's go. Question 4, 5 minutes. Okay. Yes.
No, that maybe okay. Supposed to be 2 minutes. What is the answer? Yeah, you need to do the M1 and 2 one. Because this dy over there is gradient of the tangent. I didn't mean it. Okay lah. This one is okay one lah. Okay, that one. Aiyo, sister, this one is exact form ah. Exact form is e pi square root 2.
Oh, correct.
Okay ah.
Yeah. Yeah.
They can.
Wait on.
Let me see. Negative 1 over 2e minus 1. Radian.
Wait, what?
What's x huh? Oh, 真的，我有听吗 ？Okay I'm going to help you Okay, 你好 let me see yours. Okay, Miss O one also correct. Okay, just for recording purposes, because we also have to let Regis see this Okay, short one. Dy over dx. This is equals to 2e2x minus 1 when x equals to 1, dy over dx is 2e2 minus 1 over here. Okay, so this is your m1, m2 equals to negative 1. So if my m1 is 2e2 minus 1 times m2 equals to negative 1, m2, which is the gradient of the normal, negative 1 divided by 2e2 minus 1 over here. Okay, everybody managed to get that. Okay, very good. Can Loli? Okay, this is exact form, by the way. Okay, now question 5, let's do together. Let's do together over here. Now, a sphere with center O and radius 3, okay, is inscribed in a right circular cone with height h, such that the sphere is in contact with the curved surface area and the base of the cone. P, Q are points on the contact, okay, between the sphere and the cone. Given that BAQ, okay, we are to show that tangent theta is equal to this. Now, can I just get some ideas from the students, your thought processes? When you see this question, what immediately comes to your head? Don't tell me blank. Give me something other than blank. So when we see this question, what is something that y'all would pick up on that I must go and do this one? What is something that will come to your head? Find h. Okay, that's the first thing that you come to your head. Find h. But h already found already. H is here. Find the value of h over here. Okay. So what other thought processes do you have? Write down the information. What information can we write down? Here over here is 3, is it? Okay. So radius of the sphere, is it? Sorry. So radius of the sphere. So over here, this is 3 over here. Okay. Anything else? I need something that is useful for us. Yes, okay, write down 3 is okay, that's good. But any other information that's coming to you when you're seeing this kind of question? Wait, nobody said anything about tangent. You never feel that, hey, I need to do something about tangent. Pythagoras theorem, Oh, you're okay. So you're about to say, is it about to say? Okay, very. If you're about to say, that's very good. So tangent theta is equals to opposite over adjacent, right? Okay. So there's only one theta over here, which is this portion. Agree? Okay. So that means this is our starting point. And then so this one over here will be my opposite, right? Okay, I just write here, this is an opposite, and this portion over here will be my adjacent, correct? Tangent theta, right? Okay, okay, very good. Okay, now what is the next thing that come to your anything?
Adjacent is H.
Adjacent is H over here. Okay, adjacent is H. Okay, very nice. And then anything else?
The small tiny part there is.
Where? This part over here? What do you say? This small part over here is H minus 6, is it? Okay. Very good, very good. We are trying to explore. I'm not going to give you the answer, but then what? Anything else? Hypotenuse, what about our hypotenuse? Okay, so is this the triangle that we are looking at? Or is there another triangle that we should be looking at? No, you always look at me like that. I'm just asking the class. So what you have given out is very good, but then sine room. Sister, you just throw me. You just say sine root cosine. Huh?
Sine minus 90.
Sine minus 90 or like supplementary or complementary angle. Okay, now just question for the class. Is this the only rectangle that we can employ our, no, right? What other rectangle, whatever right angle triangle can we find? Huh? The other side. Sister, it's not very helpful, right? If I flip, this one not very helpful already. You say go and find this one. Is there any other triangle? So, okay. Okay, I give you a clue. Don't give clue. Okay, don't give clue. Okay, come. Which is good. Learning process. Okay, there's another triangle that I'm supposed to look at. APO, thank you very much. So over here, so what kind of, this one is 90-degree, right? Interesting, yeah, so okay, so this one is 3, right? Radius is 3 over here, but then I still haven't found anything that is helpful for me. So is there anything else I can do? 5? Thank you very much. How do I find P? Yes, thank you very much. You see, I will now give you answer. So from Ellis triangle over here, we can find out what is our PA or AP, right? Whatever you want to find. PA is equals to Pythagoras theorem, right? So what minus what? H minus, this is H minus 3, right? Agree? So this is H minus 3 square. H minus 3 square minus, thank you very much. This one will be 3 square over here. So if that's the case, I expand this out. This will be H square minus 6H plus 9 minus 9 over here. So in this case, right, we should have something along these lines. H square minus 6H over here. Okay, now I have an expression which is this portion. This is square root H square minus 6H. So tangent is opposite over adjacent. This is my opposite. This is my adjacent over here. So let me just write out. Tangent theta is equals to OP over PA over here. Okay, so tangent theta is equals to 3 divided the expression which you have just found, which is this one over here. H squared minus 6H. Now, this is the only difficult part, right? Right, for this question over here. Now, can I just get you all to do question part 2 and part 3? Remember, for question part 3, you have to go and check, right, with your second derivative over here. Okay, everybody, can you all please go and try question part 2 and part 3 by yourself? I give you all 7 minutes. Every 1 mark will be 1 minute over here. Okay, so are we okay? Yeah, let's go. Go and find out what is your part 2 and part 3. You need the okay. Volume of a cone. What is the general formula of a cone? Yeah, then, yeah, okay, then 1/3 pi r square h, right? Okay, this one over here you have your tangent, right? Sorry, this one over here is a tangent, right? This is also equal to this one over here, correct? Right? So you can use this information to find out what is the radius over here. Okay, okay. Sorry? That is the radius of a sphere. Yeah. The radius of the sphere is 3, yeah. The radius over here is 3, yeah, we need to go and find out what's BQ. Then it's like 10 hours. Yeah, I was thinking, what would you do? What do we supposed to do? Are you so small? I'm so my class. Okay, sorry. So tangent is opposite over the same. Yeah, this one is BQ over AQ is equal to this. Agree? Now, BQ is only apparent. We got AQ, but then it's AQ. BQ. By the way, this is the radius times AQ. Okay. So I start the say my easy. 你好哈，OK，这没有问题。尾数说是什么呢？this one the I R C 对我为my R by Okay, come. Elise, okay, I help you. You go also. You don't know how to start, huh? Okay, wait, very deep. Okay. No. Okay. Come over here. Now, Singing and Angeline, are we okay? No, not okay, huh? Okay, let me just share this portion with you all. Okay, now over here, right, we have the tangent theta equals to this expression, agree? Now, if we look at this particular triangle over here, it's also tangent theta equals to BQ over AQ over here, agree? Okay, so let me just write here. So I'm just going to zoom out. Can I just write it this way? Tangent theta is equals to BQ, which is the radius of the cone, over my AQ over here. Agreed? Okay, so BQ is just BQ and AQ is H. Agreed? Now, we already got an expression for my tangent theta, which is this. So can I just write this down? Okay, this is H squared minus 6H over here. So my BQ is equals to 3H over square root H squared minus 6H over here. Okay. Now, volume is 1/3 pi R square H, which is equals to 1/3 pi. This is 3H over square root H squared over 6H times my H over here. This one is a square. Okay. Now, just copy this down until here. And then after that, I'll just expand it out. This one is 1/3 pi 9H squared over, this one don't have square root anymore. This one will be H squared over 6H times my H over here. Agree? Now, the H can be cancelled, can cancel the below stuff. And then the 3 also can be cancelled. So let me just show you. This 3 and this 9 can be cancelled away. This H can cancel with this H and this one over here. So my final one is pi times 3H squared over H minus 6. And in this case, if I multiply everything together, this one will be 3 pi H squared over H minus 6 over here. Okay. Okay, now copy this down. Anybody lost? No, not lost. Okay, now if you're not lost, can you all just share with me? Given that H can vary, find the value of H for which V is minimum. What should I be doing? dy over dx, okay, but in this case, there's no y and x, so it should be, yes, dv over dh is equals to 0 over here. So very close, Nihao. So I will have 3. No, this is my V over here. So V is equals to, ayu, this is a long step. Oh, can you all go and differentiate? Use quotient rule. I don't know how to simplify. Okay, let's go and do our dV over dH together. I'm going to use my quotient rule. So bottom over here will be h minus 6 squared. Differentiate my top will be 6 pi h. Then I copy the bottom, which is h minus 6. Minus sign, differentiate the bottom, which is 1. And copy the top, which is 3 pi h squared. Okay, so everybody, let's go and multiply them. 6 pi h squared minus 36 pi h minus 3 pi h squared over this. I know it's an atrocity to go and differentiate at 8:30 at night, but still, we have to go and differentiate using quotient rule. Now, we can simplify, right? The 6 pi h squared and the negative 3 pi h squared can be cancelled away. So I will have 3 pi h squared minus 36 pi h over h minus 6 squared over here. Okay. Okay, now, following what Nihal has said, right? He said dV over dH equals to 0. So let's equate this to 0. Sorry, I ran out of space, so I need to erase this. But you all more or less get the idea, right? So my dV over dH is equal to 0. So I will have 3 pi h squared minus 36 pi h divided by, which is h minus 6 squared equals to 0. Some students who are faster, they will just take the numerator equal to 0, which is totally fine. So 3 pi h squared minus 36 pi h equals to 0 over here. Now, this is the next important question for the class. What should I be doing? Factorize? Which one? Oh, yes, thank you very much. So I have 3h. This one will be pi h minus 12 pi over here equals to 0. 3h equals to 0. H equals to 0. Now, this is one of your answer, but you have to reject, right? Because you cannot have anything that h equals to 0. Doesn't make sense. My next answer will be pi h equals to 12 pi over here. So h is equals to 12. Okay. So the value, they say find a value of h which the v is a minimum. I can also lah. But they say 3h lah, so I just follow them. But also can, yeah. If you factorize out your pi also can. But then you will have two answers. One is h equals to 0, which you must reject, and then you have h equals to 12 over here. Now, are we done? Is this our 4 marks? No, boy. Okay, Audrey, what is missing? Sub in, huh? Sub in where? Into V, huh? But in this case, right, I need to ascertain for myself, right, that V is a minimum. How do I know that V is a minimum? Yeah, you're on the right page already. Yeah, that was the page that I said. So what should I be doing? D square V over DH square, right? Okay, can everybody go and differentiate this atrocious function again? And go and find out what is the expression. Then you sub h equals to 12 into the equation. It must be greater than 0. Yes, I know you ran out of space, but let's go. How do you differentiate, huh? Which one you want? Yes, we'll use another quotient rule. Yeah, we. Okay, go and find. Okay, go and use a foolscap paper or whatever. Go and. Is there another alternative page? Is there a quiz page? Okay. Can pass around the
Yeah, I know they say no space, so okay, we've got space for you already. Okay, come differentiate again, everybody. Yes. Train your differentiation. Yeah. Also something. Yeah, the pasta. Yeah. Yeah. Wait, why are you eliminating? 6 pi h, okay. Oh no, then 36 pi. Okay, wait. Do you want to use your first derivative test or your second derivative? Both also
The either
second. This is second. Second. Okay, now let's do this atrocious differentiation. Okay, come, let's do this. Okay, now second derivative, right? D square V over dH square. I have to square the bottom. So in this case, I square the bottom will be this. I differentiate the top will be 3 pi. Sorry, I fast one, 6 pi h minus 36 pi. Copy the bottom, which is this, minus differentiate the bottom, and then I copy the top over here. Okay, so this is my differentiated one. Okay. Now, just sub it in. At this point, don't go expand out. Don't make my life difficult also. So when my h is equals to 6 over here, my d square v over dh square. Okay, I'm gonna fast forward for everybody. Let me see. This one will be 36 pi minus 36 pi. Wow, so nice. Which the whole thing is 0. Is it 12, right? 12, right? Okay, sorry. Oh my goodness, I thought I have 0 everything. So this one will be 12. 72 pi, right? 72 pi minus 36 pi. This one should be 36, right? Minus, this is 2 times 6, which is 12. What is 144? 144 times 3 is 432. 432 pi minus, what is 36 times 12? 432, right. Right. What is 6 to the power of 4? 1296. So this part, the whole thing is 0. Agree? Okay, so I would have 36 times 36 is 1296 pi divided by 1296 over here, which is equals to pi, right? Which is greater than 0. So in this case, this is a minimum value. Okay, a minimum point. Okay, so this is your final answer. This is the fastest way I know how to do. Okay, just copy. Just copy. I know your brain fried already. It's like that one. Are we okay? Okay. You all feel confident? I say this last one a lot. You all feel confident doing this kind of questions? More or less, right? More or less, right? Okay, next week if I do a time practice, hang on.
But must do homework first, So okay, can time practice. Okay, So next week I will do time practice. Now, I don't think I want to do any more exam paper anymore. Let's go back to our textbook, shall we? We last left off at integration. I only have 20 minutes with you all. So can we just do a bit of integration? Okay, so this one will be the last question. Where did we last left off? I forgot. Oh, we haven't even. Oh no. Yeah, even finished the this portion. No, he didn't. I didn't. Oh, I haven't started yet. Yeah, we never started completely. The integration. No, this me doing.
We never do it.
I think on fire, right? Oh, yeah, let's just do integration. Next week, then we do the remaining part because I think if we start to do again, then we need to brain power. Okay, come. Let's start with something very, very simple. Okay, integration over here. Okay, now 20 minutes, y'all just enjoy whatever that I will be going through. Where is one? Okay, come. Integration over here. Give me. Where is my integration? Oh, okay. Easy stuff. Okay, now, you'll just enjoy the lesson. I'll just let y'all know what is integration all about. Just an idea. You all have done integration in school, right? The both of you. You also, right? The rest of you, everybody have done. Oh no, have not done integration. Not yet. You all have done it already. Where are you all at right now for integration? Or Trigo, you? Too fast. Then you all? Oh, still on numbers, algebraic function. Okay. Now, this one just enjoy lah. I know that everybody's tired already. Okay, now, first and foremost, if I ask the class, what is the area over here? What will you tell me? Yeah, so 4 times 8 over here, right? So simple enough to understand. I have 4 units over here. I have 8 units. So 4 times 8 is equals to 32. So easy peasy. Now, if I continue on the same line of questioning, you will tell me, Teacher Wilson, this one is very easy. This is half times base times height over here. Okay, so in this case, this one will be half times 7 times 4 over here, which is equals to 14, right? 14 units squared. Okay, so now, like that, it becomes a bit more difficult, right? Now, some students will say that, Teacher Wilson, this one still can. I won't give you the exact answer, but I give you an approximate. So some students will say, I can do a 1 by 1 block over here. One block, this is 1 cm square, 1 cm square, or 1 unit square, 1 unit square. And then they do this, which is okay. So let's use Lego blocks. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So some students will say, Teacher Wilson, this is approximately 17 units square, which is very good. I'm very happy because that it shows you that, okay, you have some idea on how to find out the area. Now, if I change it in such a way that it is like this, okay, I say that, okay, I have a certain width and I have certain length over here. I can find out what is this area, and then I add this, this, right? I will get an answer that is very close to the actual answer over here. Actual answer, right? Okay, now this is the idea of integration over here. Now, integration is the process of accumulating quantities over an interval. Okay. Now, differentiation measures the rate of change of something, right? So like your dy over dx, the rate of change of y over the rate of change of x over here. But your integration is your accumulating areas across a period. Now, that's why your teacher will definitely tell you in class, the integration is the reverse process of your differentiation. Now, you will definitely learn this. This is kinematics, but in your A math, you will experience this one. Yeah, so if your speed time graph, okay, this is your speed over here. If you find the area under the graph, you will get the distance. So this is the integration part. Now, if I find the gradient of my distance time graph over here, this will give me my speed. So that's why integration and differentiation is the reverse process of each other. Okay, easy stuff. Okay, now, so let's take a look. So I think it will be quite easy for some of you all. Now, let's just write out whatever that we need to write out over here. Now, page 186. So when we are looking at our integration over here, very, very easy. This is known as your integral sign. Okay. So if I want to integrate an algebraic function with respect to dx over here, the thing is, instead of -1, the power will +1, and you divide by a new power. Okay. Now, for those who have done integration, right? Later, can I ask you all, what is this plus c all about? Okay, so you just need to know that my power was +1, and I have to divide it by the new power over here. So let's go and understand. So the process of integration, because it's reversible, if I differentiate this, I would have 12x cubed. But when I integrate this, the coefficient, I leave it by itself. The power is 3 plus 1 divided by 3 plus 1, and then I have a plus c over here. So this one will be 12x to the power of 4 divided by 4 plus c. Now, copy this down. For those who have done integration, why there is a plus c over here? Yeah, but why there is a constant? Yes. And then in order to recover back that constant, we have to go and plus c. Okay. So what Angeline is talking about is whenever I have a constant in my differentiation, if I differentiate it, the constant will be disappeared. To recover that constant, we will always plus c when we are integrating back. Okay, so that's why we have the plus c at the end of our function. Okay, very good. So what you have to write here is the power will be m plus 1. I need to divide it by m plus 1 over here. Okay, power m plus 1. So divide by new power over here. So whatever the Angeline has just said, right, is when we try to differentiate, you see, all these are constants over here. When I differentiate it, I will just get an x cubed, 12x cubed over here. So the constant disappears. So to recover that, this will be 3x to the power of 4 plus c over here. Okay, so we are adding the constant to recover your one that is lost. Okay, so we'll just do one very small exercise over here. By the way, can you all turn to the next page, page 187? For those who have done integration, you all can continue to fill up all these cells over here. For those who have not done this, let's go and take a look. Okay, so for Lolin and Audrey, who's Andrea? Audrey over here. Okay, this is known as your indefinite integral. So once again, if integrate 2x cubed with respect to dx, just remember the coefficient, you leave it by itself. The power plus 1 divided by new power. And remember the plus c over here. So this one will be 2x to the power of 4 divided by 4 plus c. So in this case, I will have half x to the power of 4 plus c over here. Okay, now your habit is now to plus c already. You are changing from integration, from differentiation to integration. So always remember to add your constants over here. Okay. Audrey and Loli. No, not okay, huh? So the process, the mechanics of it, or don't understand the whole thing. Okay, so let's take a look at this one. If I want to integrate 7x squared with respect to dx over here, so number one thing, I leave the coefficient by itself. I don't touch it. So this one will be 7. Now the x term is the one that I want to affect. So this one will be x. Now the power in differentiation we will minus 1, correct? But in integration we must plus 1. So this one will be 2 plus 1. And then we need to divide by the new power, which is this one. Okay, so this one will be 2 plus 1 plus c over here. Okay, so in this case it will be 7x cubed over 3 plus c. Now, question C over here. Elise, please help me. How do I set up my integral such that I can better integrate this? Agree or not? Xing Yi, Angeline. Agree for this one? Question C over here. No. Yeah? No. Why? The 3 won't be below, right? So in this case, right, over here, this should be 1/3. Okay. Okay, so in this case, if I integrate the coefficient, I leave it by itself, the x will be plus 1, right? So Xing Yi, what do I have? Minus plus 1, then it becomes? Yes, thank you very much. Okay, minus 4 over here divided by minus 4 plus c. So in this case, I should have 1 over negative 12x to the power of 4 plus c. Okay, now final one. Let's question D over here. I want to integrate square root of x. Angeline, what do I have for this one? X to the power of half with respect to dx. So if I integrate this, this one will be x to the power of? Yes, 3 over 2 divided by the new power, which is 3 over 2 plus c. So this one will be 2 over 3 x to the power of 3 over 2 plus c over here. Okay. Now, please continue on the question E, F, and G. For those who are done, that's fantastic. Let me just go around. For those who have not done it, please go and finish up E, F, and G over here. Okay, come. This will be the final question already. Let's go. So if I integrate 8, what happens? Okay. Because my x is 0, right? So over here, yes, thank you very much. Hey, you're forgetting something? Yes. Cindy, I'm really gonna miss you now. Yes, continue. Plus what? Yes. Wait, wait, x times x one divided by x. Yes, correct. Okay. Okay. When I ask when your school goes through integration, is it too fast for you? No chill okay. For you is chill, yours is chill. Okay, can. Okay, okay. Do I have everybody's WA2 dates? I don't have Ian House. I don't have Miss Po. I don't have Angeline and Xing Yi. I have Audrey's one. I also have Lolin. Now, don't have 没有 Then 12 May 12 May. What are the topics? Everything else before integration, is it? Bro. Okay. So how far is your integration? How far are you going to test for integration? Everything, even the hands question, GG, man. Yeah, got hands question. That one is quite difficult. Hands. Not the chicken hand Bro, not the chicken hand one. Then you want? 8 May 8 May over here. Everything else before integration, is it? No integration. Okay. I don't count. Okay, can. Wait, same school?
Same school. I thought this is same textbook.
Oh, same textbook. I thought same school. Okay. I thought you all same school one. Okay. Binomial. Cannot. How was yesterday's one? Okay, you all watch you all watch. you know you will come for the last part. So you watch the
Yeah, I get my result.
Oh, yours is WA1, right? Okay, can just let me know. I think should be good, right? There's only that.
So I passed Kenny.
Who knows, right? Who knows? Another double miracle. Let's have it. Yes. Okay, so that's it for today. Anybody needs to let me mark their homework? Who managed to? You all go finish our homework. I need to go and mark. Okay, that's it for today. Thank you very much. See you all. Take care. Bye bye.